Everyone, my name is Ankit Verma and you are watching my channel Engineering Tutor. This is lecture number 39 in which we will discuss some important concepts of center of mass. Particular topics of this lecture will be center of mass of finite solid bodies. Like we will discuss center of mass for the uniform rod, non-uniform rod, like semicircular ring और डिस्क ट्रायंगुलर पोर्शन, कैसे हम उनका सेंटर ऑफ मास निकालते हैं, ये सब चीज़ हम देखेंगे. एंड वी विल डिस्कस और कैलकुलेट द सेंटर ऑफ मास बाय इंटीग्रेशन. सो इंटीग्रेशन इज रियली इम्पॉर्टेंट. इंटीग्रेशन में आपको बहुत स्ट्रांग होना पड़ेगा, इसमें सिर्फ इंटीग्रेशन लगने वाला है. सो लेट्स डिस्कस. सपोज this is a body. It is made up of number of particles. Suppose there are 3 particles, 1, 2 and 3 particles. Distance from the origin will be R1, R2 and R3 and so on. We have already discussed that RCM equals to summation M upon summation. And these masses are small masses. Okay, small masses. So this was RCM. If as we know that this delta M is very small. This delta M is very small. So in general, in integration point of view, we can write R dm, okay, on integration dm, because delta m is just equivalent to dm. But if you want to integrate or use integrate, you have to use differentiate portion. Then only you can apply the integration, just like y dx. Okay, so if you integrate it, so you can find out the area under the curve. तो इस तरीके से हम इसका इस्तेमाल कर सकते हैं. सो ये है जनरल फार्मूला. दिस इज द जनरल फार्मूला दैट वी विल यूज, और बहुत शानदार तरीके से हम इसका इस्तेमाल करने वाले हैं, यूज करने वाले हैं. देखिए, जैसे कि मैं आप जनरल वे में लिख देता हूँ. सपोज इन एक्स डायरेक्शन द एक्स कोऑर्डिनेट फॉर द सेंटर ऑफ मास विल बी सिमिलरली दैट एक्स डी एम अपॉन, okay, similarly y and similarly z if it is in 3D. Okay, suppose you have to remember 3 mass densities, like linear mass density, like in 1 dimension. Okay, suppose this is a, okay, so for that you have to use linear mass density, that is denoted by lambda. And if you want to calculate the mass of some particular portion, suppose this length is dx, linear means length, suppose this distance is dx. So if you multiply lambda with dx, the mass of this small portion, let AB, will be find out. Lambda into length. Okay, suppose there is a body that have 2 dimensions. For that portion, so that will have some area. Suppose this is portion AB. Okay, for that we will use area mass density. Area mass density, that is denoted by sigma. Okay, for that portion, if you want to calculate the mass of this portion, that will be sigma dot dA. Okay, and similarly the, for जो हमें आज तक पता ही है, जो वॉल्यूम मास डेंसिटी पढ़ते आए हैं. Okay, so if you want to calculate the mass of the 3D body or that have some volume, suppose this is a cylindrical piece that have some radius as well as height, so it's a 3D body. In fact, we will use this concept, mass equals to density into volume. If dV is the volume of this small portion, so we will use rho as the volume mass density, volume density, volume mass density, volume density, and sigma is area mass density, and lambda is what? Linear mass density. Okay, suppose let me discuss a uniform rod that you have to find out the center of mass. और मैं आपको एक बात बता दूं, अगर आपको ये सब चीज सेंटर ऑफ मास निकालना आता है तभी आप मोमेंट ऑफ इनर्शिया में अपना कंसेप्ट बिल्ड कर सकते हो. अगर यही समझ नहीं आएगा तो मोमेंट ऑफ इनर्शिया बिल्कुल भी नहीं आएगा. सपोज दिस इज अ यूनिफॉर्म रोड. सपोज you have to consider a portion that has length dx. It is having a distance x from this portion, from the end of the rod, and this is uniformly distributed rod, uniform rod, so the mass distribution is uniform, or we can say that uniformly mass distribution is here. For that, lambda dot dx mass equals to, I have already discussed. Also, suppose the length of the rod is L and the linear mass density is lambda. So we know that lambda equals to m upon n. So we can put this value here. So dm equals to m upon L dx. So this will be the mass. Nothing else. Okay, so if you want to calculate the x coordinate of center of mass, that will be x dm upon integration dm. Okay, so put it here. What is dm? M upon L dx upon m upon L is constant. M upon L is constant. So here m upon L will be cancel out. This will be on integration. कहाँ से कहाँ तक करना? 0 से L. From here length is 0 and from up to here length is L. So you have to integrate this from 0 to L. So from here XCM will be L by 2. This will be the answer. Okay, so for the linear bodies that we will use linear mass density, only the x coordinate is important क्योंकि ये दूसरी डायरेक्शन में है ही नहीं. So from here this will be L by 2. So center of mass will be in the center of the rod. Let this be seen. Suppose let me discuss a case that is really important जिसमें न्यूमेरिकल भी अच्छे से बन सकता है कि रोड इज नॉन यूनिफॉर्म. रोड इज नॉन यूनिफॉर्म. रोड मीन्स, or what is non-uniformity? The road will depend on distance. Suppose this is a distance x. In this direction we can say that, and the linear mass density is given as bx square, for example. Okay, what is lambda? This is mass per unit length. This is mass per unit length. This is fixed always. We know that dm equals to lambda dx, isn't it? Okay, this is lambda dx. So from here dm equals to, what is lambda? Lambda is bx square dx. ठीक है, तो XCM will be calculated. That will be x dm upon integration